Hello, everybody. We have another edition of the weekly BOS Code reviews every Thursday at 11 a.m. Eastern time. And for all of you who don't know, this is a Marketing DAO, Build DAO supported weekly code review session where we go over the latest BOS components from people who made it, or review other people's work, or we go over contracts or infrastructure. Really, whatever you're feeling, we're here to make new content. And today we have Prometheus, who is a developer, a backend developer, and a smart contract developer, and one of the first NFT BOS developers on BOS. And yeah, one of the devs behind Genedrop and Minority Programmers. And today he's going to be showing us how to mint NFTs on multiple chains. So if you guys don't know what BOS is the blockchain operating system. It's essentially front-end components built on JSX that you can save on chain, and there are these gateways that have this VM that interpret these pieces of code. And it's kind of limited where you can't import external dependencies and npm packages, but it does have Ethers.js and Near API.js built in, so you can connect your wallets on Near and also on EVM chains. So in this example, he'll be kind of going over how exactly to create a multi-chain minter. So without further ado, Prometheus, if you want to do the honors.
Yeah. Hi guys. So my name is Prometheus, and in this session, I'm going to be taking us through the Genedrop multi-chain minter. So basically, this component allows you to mint your NFT on a couple of chains, about 4 or 5 chains. We're going to be seeing that later. But if you just get started with BOS, BOS has a docs page where you can see all the things that are present that you could use. Like Short said, there's the Ethers API, and then there's the Near's API for start, and then you can also style your components as we're going to be seeing. But I'm just going to be giving us a quick walkthrough of the app first, and then we're going to be jumping into the code and seeing how it was actually built. So this is the page, and it allows you to upload an image. So you can select an image, and I'm just going to be selecting one of my images and see. And then he uploads this image to IPFS, and then it displays it here, as you can see. So I'm connected already to my MetaMask because I've used this component before, but you can switch, as you can see here. This is why we call it multi-chain. You can switch to any of these chains and just mint your NFT there. So like I said earlier, we support Polygon, Aurora, Celo, Avalanche, Arbitrum, and Near itself. So I'm just going to try and switch to Celo. And then click on switch network, and as you can see, it switched to Celo. I can switch to Polygon.
And so you're using MetaMask injected wallet. Right now we can actually see the pop-up for MetaMask, but I'm assuming it's triggering you to switch network. I think you have to share your window if
I think for privacy stuff. Yeah, so you might not be able to see my MetaMask pop up, maybe for privacy reasons, but yeah, it's popping up and asking me to switch network. So once I click on the chain I want, MetaMask pops up, and then I click on switch network, and then it just switches to that network. And as you can see, we are now on Polygon. So also we have soulbound NFTs integrated to this component, but I'm probably not going to be showing us that. But it's basically you can mint soulbound NFTs on Genedrop. So I'm going to be giving this this NFT random title. Forgive my descriptions. And you could mint to a different address. So this is going to be, if I do nothing now, it's going to be minting this NFT to my address. But if I wanted to mint this NFT on behalf of someone, say to a different address, all I have to do is pick the person's wallet address and paste it in this mint toolbox, and it's going to actually mint this NFT to that individual's address. But in this case, I want this NFT in my address because I love this NFT. So I'm just going to leave it at that, and I'm going to click on mint. And again, you might not be able to see this, but it pops up MetaMask for me to confirm this transaction, and then I'm going to click on confirm transaction. And then we're going to just wait a bit for the transaction to be confirmed on the blockchain. And once that is done, we are going to present it with the transaction link where we can actually check that this transaction actually went through. So yeah, we click on view transaction and we can see, it's still indexing on Polygon scan. We'll give it a couple of minutes and we see that this NFT has been minted. So yeah, this NFT was successfully minted, and I could just switch to any other chain, and then I could also mint it. But I would like us to just jump into the code first and actually see the code behind this component. So
Yeah.
I think the main
Yeah, and just to clarify,
what?
like if you had gas in your wallet, two minties, it says you have 0.4 Polygon. So yeah, you're gonna need enough gas to mint this for these purposes too. But
Yeah. So if you could see the little widget over here, this is my address and this is the amount of matrix I have. So you do have to have some matrix if it's on Polygon, and there's some Celo if it's on Celo or any respective blockchain. So I was saying the main important thing behind this is being able to switch between these networks. Like I said, as you saw earlier, that we have a couple of networks. We have like 5. Although we could classify them as 2 different ones, because there's near, which is different from the VM ones, like Polygon, Celo, Avalanche, and Arbitrum. They are all Ethereum compatible networks, so it makes them we can group them together. But the main thing that makes us be able to like switch network between these components is just the state management. So if we're able to manage the state well, we'll be able to like switch between one network from the other. And I'm going to be showing us that just now.
can you outline the setup first, because you have all these contracts imported, you have things for soulbound contracts, and you have also for near, and I think there's also respective ABI. So like before you go on like kind of handling the data, which contracts are which, like what does it actually take to so like Genodrop has their own NFT minting contracts for all of these chains, and then for the EVM, the soulbound as well. So can you kind of outline just like the setup?
Yeah, so because we have like 5 different chains, there is different NFT contracts on each chain. So we have to bring in the contract addresses for these NFTs. So there's the Aurora contract, there's the Aurora Soul contract. So like I said earlier when I was mentioning, we also have soulbound NFTs incorporated into this component. So for each network, there's the normal ERC 115 NFT contract, and there's the soulbound contract. So for Aurora, for Polygon, for Celo, for Avalanche, which is also called Avax, for Arbitrum, and then for Near. So Near is like the CNFT, the Banyan of Near, quite readable. And then the owner ID of this component for attribution sake, as you can see here. So we also have this thing. So this is called the ABI. So basically the ABI allows you to be able to like interact with your smart contract. So that you just specify the functions that are present in this contract, and this would allow you to be able to actually call this contract without being in this contract or having it in the contract. So the account ID
to that, the API part of things, because so this is like an application with binary interface, and usually like how do you get this ABI? Do you have to be the one to deploy the contract? I know you publish the ABIs on the repo, but is this like a limited version of the API? Is this the whole ABI? Usually I've seen people like take like a GitHub upload and then reference that and like fetch it from GitHub and then reference the API. Why do you do it function by function? And can you kind of explain that process?
Yes. So this is like one of 2 ways of how you can use the API. So basically there is normally an API file generated for each contract that you write. Now this API file is actually might be quite a lot. And for BOS, what we do is like we store it in say a gist file, and then we use the fetch API on BOS to like fetch this API from the gist. But this is for me, this is easier and more straightforward. So if you for each contract, as you can see here, this is a mint function. So this is how functions are written in Solidity. So what you specify in here is just the function that you want to call. So basically an NFT contract, there is so for every NFT contract there is a standard, that the contract has to follow. And in this standard, there's a mint function. So it means that you can be assured that every NFT contract that exists has a mint function, has this specific mint function. So this signature will always be present on every NFT contract that exists. So this is why you could use this as the API, as the point of contact to be able to call any mint function on the contract. So there's you could get the standards for the ERC15 or the standard for the ERC721, and then just copy the functions here and paste it as your API. So like I said, this is more straightforward than actually using the API file generated when you compile your contract. For me, this is actually quite straightforward and less line consumed in your components.
But
So that's basically
the
how
actual minted contract, it's a larger file. It has more functions than this. You're just selecting the ones that you're going to use for this specific component.
Yes. So basically, because I know that I'm only going to be interacting with two functions from the contract, I can minimize and use this very minimal API to be able to do everything that I want to do.
Can you explain that process a little bit deeper? So this is only for Ethereum. On Near with the API.js, you can literally like, how do you know what, say you're interacting with an application or a contract and you don't have the API on Ethereum, and all you have is a contract address for Ethereum and Near. So can you kind of explain how you would go about finding this kind of limited API, and then how it differs on Near?
So I think for Ethereum, you could always go to Polygon, something like the Explorer, like Polygon Scan, and this would on the contract channel, there is always an API on there that you could, like, on every contract tab. So you could basically go there. Let me try and just see this now. I don't know if you guys can see my screen for the
Yep.
yeah. So you can see here there's a contract API here, and then you could copy this contract API. And so that was what I talked about, the API generated when you compile your contract. So on compilation, the API file is like always generated, and then you can use that API file. Like I said, once you know the sort of contract you want to interact with, for example, if it is an NFT contract, NFT contracts as a standard, so you could just I think there's a site where the ERC721 contract standards are all laid out. So you could go to that website and just copy the standard for the function you want to call, the function signature. For example, I said I was going to be calling the mint function to mint NFTs. So you're going to copy the mint function signature, and you can rest assured that as long as the contract you're interacting with is a NFT contract, then it is always going to have a mint function, and this call will always go through. So
can you go back to Polygon Scan for a second? So it actually showed the source code, which not every block explorer does. So was this contract verified? Is this standard place? I'm just trying to make sure, like, if I go to any contract, I'm able to get the API. Normally the source code isn't there. Like, what's the
this particular contract was not verified, but the only reason why there is a contract is because it is an upgradable contract. So it's sort of a proxy contract, and as you can see here, the proxy is what the proxy code is what is actually here, not the real contract code. So this proxy code is what calls the real. I think this is the source code. This is the implementation contract. That's what I was looking for, basically. So this proxy contract calls the implementation contract, and this is the address for the proxy. So your code basically calls the proxy contract, and then the proxy contract is what is responsible for actually calling the implementation contract that was given to it on deploy. So basically, this code here is not the source code for the implementation contract, but the source code for the proxy contract that calls the implementation contract. I don't know if you get what I'm saying.
And so yeah, it's just detecting. So from the bytecode, it can interpret the ABI no matter like, and now based on
Yeah,
it's determining like what contracts you're similar to, and this displaying kind of like similar source code. So no matter what contract is deployed on any kind of EVM chain, you can get the ABI from the block explorer. Is that
yes.
okay? Awesome. So in theory, if someone wants to use a particular function on any contract despite having the source code, they can begin to interact with it on BOS by kind of doing
Yeah.
it. All right, awesome. Yeah, but near it's different. Like near, how would you do this on near if you only had the contract on here? Like, is it similar on the near block explorer, or like how does it differ from what's on Ethereum?
So for near, I think so. There's this new explorer which actually which decompiles the code that is deployed on the address that you give to it, and actually lists out all the all the functions that are callable on that contract. Yeah, but you might have to do a bit of research on your own end when it comes to the near part to be able to like know the function that you actually want to call on the contract. So there's nothing really like the Ethereum part where you can actually see the API that you're looking for. So if you check how we're calling the function on near here with the near API.js, I'm just trying to. So we are doing a near call, and you have to, for example, you have to know the name of the method you're calling and then the arguments that that method takes. So if you miss the argument, say by one, the contract is going to panic. Although the contract is actually going to tell you which exact argument name is missing, but it's going to panic nonetheless. So basically, you have to for near, you have to like know the name of the NFT, the name of the method that you want to call. For this case, the NFT mint, and then you have to know the arguments that are given to it. But then again, Near also has standards for its NFT contracts. So basically, you could check out the NFT standards, the standards for NFT contracts, and that way you could like get the name of the contract, the name of the method that is responsible for calling mint functions and any other function you'd like to call.
Okay, yeah, and he's referring to near blocks, which has a like a contract section where you can actually see
Yeah,
all.
yeah. So near block. So yeah, that's what I'm saying. That near block, you could actually. So let me try and see. So the near extra is called nearblocks.io, and you could basically paste the contract address on it, and it's you can go to the contract tab after that. I don't know what's going on. Okay. Yes, so there's a contract methods tab, and then you could see here that there's a whole lot of function methods, method name basically that you could call, and you can see now in our components we were calling this specific NFT, we're calling this NFT mint function, and but there's a whole lot of other method names that you could call. There's the NFT approve to approve functions. There is the NFT transfer. Although you should be careful, some of these functions, like these ones, they are what we call private functions that you can actually query them. So if you copy this function, this method name, and you try to query it, the contract is going to panic because you're not supposed to be able to like query this function name outside the contract. So you can only query public functions like the NFT mint. So the NFT standards, if you are able to get a hold of the NFT, I actually didn't come prepared with that. But if you are able to get a hold of the NFT standard for near, you could be able to see all the public functions that you are supposed to call, like the NFT mint for minting, the NFT transfer method name for transfer, and then the NFT underscore approved method name for approving accounts to transfer and do anything with your name or with your NFT. So yeah, that's what it is about ABIs. So this is the ABI for Ethereum, and so we basically have an object where we group all these we grouped all the networks that we have by their chain ID. So this is the chain ID for Polygon, this is the chain ID for Aurora, chain ID for Celo, chain ID for Avax, chain ID for Arbitrum, and so basically Near does not really have a chain ID. It does not really have a chain ID, so we just give it a chain ID of 0. Yeah, so that's just what we give it for the sake of this component basically. And then we have an array where we group them again, the ID, the name, and then the URL for. So this is basically just a little bit sort of a logo where we could be able to display in the drop down here. So yeah, so that you could be able to like display a little bit logo there. That's why we have it here. For every of the chains that we have it there. So we have this function handle mint. This is what handles minting, but I don't we're not going to go into that yet, I suppose. So what we do now is we initialize our state. So basically we initialize our state with some default variables. For example, title, description, recipient, if it is so bound, show alert, toast message, image, etc. We're going to come to what this means in a bit, but I think these ones are self-descriptive. For example, the title of the NFT means the title of the NFT, the description of the NFT. Sorry about that. Yeah, the title of the NFT, description of the NFT, the recipient, which is the person you are minting to. If you are minting to someone, like I said earlier, yeah, that I could put an address here and then it would mint to that person. And then this is a toast message that actually just allows us to show error messages. For example, if you're trying to mint an NFT and you do not put a title, it's going to like tell you to put a title. Let's just try that. So if I delete the title and the description I try to mint, you could see there is a little stuff there that told me to please enter a title for the NFT. So that is basically what the show alert and toast message stuff is for. So
And can you go over like right now this, I mean, this was made a while ago, but since then we've covered in the last videos use state, use effect, use memo, and I think use callback or like React hooks are now supported in your social VM. So a lot of people are transitioning from that state init to use state.
yeah, so because it's been a while that I built this component and I basically did look back after building it. I haven't updated the state management to using to the use hooks that was newly installed to the VM. So maybe I'll get around to do that later on. But for now, we're using the pure state function to like just do state init and state update. So basically, once we initialize our state here, we could do state update to update any state that we want to, as you can see here, and we select state, and then we use the state to update directly the select is open state variable here that we initialized as false, and then we update that variable to whatever it's supposed to be. But yeah, we're using the for this component, I'm using the state the pure state update functions that was provided formally on the VM to do that. So also for styling, we used a mixture of styled components and some bootstrap for buttons, but majorly we used style components to like do stylings for the image cards, the text, the inputs, the text area, the chain icons. So we basically used styled components for that. There is we could use Bootstrap to also do our stylings, but personally, I think I found styled components to be I wouldn't say easier for me, but I just really found it cooler for me to use than Bootstrap really. I feel Bootstrap is like outdated now. Yeah. So so for styling, we use styled components and a mixture of Bootstrap for especially for buttons, like I said. And that's that. So this is basically the components, and something about BOS is the fact that components are composable, so you could basically use other components in your components. And for example, this general alert is what is responsible for these alert buttons here that you see. So I didn't basically, so you could argue that I actually didn't build that alert. All I just did was I found someone who's built the alert widget, and I imported it sort of into my own components. So if I create the state and said that if the show alert state variable is true, then basically that means that someone is doing something wrong, and just display this widget, this alert widget, and pass in the state. So the widget, if you go to this particular widget code, you will see what it's doing there. It's basically going to be I mean, it's not like I'm seeing the code right now, but what it's going to be doing is just checking through this state and getting the messages that I should display in the alert box. So basically you can see the headings for Mint NFT on multiple chains, and this image upload card is something that is provided on the go by BOS by the BOS VM. So this basically instead of you writing your own code to upload your files to IPFS, this is like an helper widget that you can just again import into your components, and it gives you this little button where you can just click on, and then it allows you to like upload any image to IPFS. So once you select any of those images, it's going to upload them straight to IPFS. So as you can see, the name suggests IPFS image upload. So since we're there, let's just start with that.
How do you get the image back? Like now that it's uploaded, like how do you where's the response?
Can you come again?
Like for this IPFS image uploader, like how do you where's the IPFS hash from this? Like where do you
Yeah,
get
so basically, like I said, you don't have to do anything yourself. This widget does, so if we are able to check this IPFS image upload widget code, what it's going to be doing is going to be calling So if you do not know what IPFS is, basically it's basically a decentralized storage system where every file you upload is assigned a unique identifier, a unique hash. So no two objects have two different objects have the same hash basically, but every object, if you upload an image, the same image 10 times, you get the same hash in return because it's the same image. So basically, that's what IPFS is. It allows you to store stuff on decentralized storage. So this widget is probably going to be calling the API to upload your file to IPFS, and then it's going to store the hash. So basically, once you call the IPFS API, it's going to return an hash. So this widget is going to store the hash in the state variable here. So you can see when I did a state init, there was an image variable that I put there here. So it's going to, so for now I initiated this CID. So the CID is basically just the identifier for the image. So once the image upload widget completes upload of your image to IPFS, it receives the hash from IPFS, and then it stores it in this variable, in this state variable. So you can be able to access it from there. So if we go down, we can see that if I upload an image, you could see there is uploading, and basically just takes a bit longer. And yeah, so you can see because of the CID, or the hash, we are able to like display a thumbnail of this image here. It might take a while for it to display here too. But you can see the thumbnail here. So we use that CID that we got back from the image upload to actually display this thumbnail here for like a preview or something like that. Yeah. So basically, once you are able to, I think one of the crucial steps in minting an NFT is basically uploading to a decentralized storage or uploading anywhere basically. And once you are able to like upload the file that you want to mint to a storage, then you are almost done with minting the NFT. So now what you just have to do is just give the NFT a title and description. So if you do not do that and then you click on mint, obviously there's going to be a little alert here that tells you to do that. And then you can always change your chain to whichever chain you'd like to mint it to. So I changed it to Celo. But again, so I think at the start I said that we're able to do all this with the state management. So if you check, there is a chain. So there is a function called on chain changed. Apologies for the name. Yeah, undo chain change. So basically, if we check where this function is at, so we make sure that once you click on these drop downs, once you click on it, we call this on chain change function, and then we pass in the chain ID that you're trying to change to. Now, once this function is called, once this function is called and we have the chain ID you're trying to change to, what we do is then that we make sure obviously we make sure that you are connected, that you have that you've connected your MetaMask, and then we send this Ethereum RPC request. So what this request is, as you can see here, is a wallet switch Ethereum change. Now, what wallet switch Ethereum change does is basically telling the MetaMask or your wallet, whatever your wallet is, not really MetaMask, it's telling your wallet that would like to switch an Ethereum chain. Like I said earlier too, most of these other chains like Celo, Polygon, Aurora, Avalanche, they are what we call Ethereum they are Ethereum compatible. So they are EVM compatible. So which means that most of the functions that apply to the Ethereum virtual machine also applies to them. And that's why you can see this RPC request name is called wallet switch Ethereum chain. And this Ether send takes just one parameter, which is like the chain ID as an object. So this is the method name. We are doing an Ether send, and then we are passing in the method. Another method that this Ether send could do is what we call wallet add Ethereum chain. So this is not including this component for now, but imagine if your wallet did not have a specific chain that we support. So for example, now this component supports Aurora, but your wallet does not have Aurora added in your wallet. We could do an ethers.send wallet add Ethereum chain, and this would help you to automatically add this network to your wallet so that you'll be able to like mint on this wallet. So, but for now, we just focus on this method called wallet switch Ethereum. So we pass in the chain ID as an X. So what this is doing is we are getting the X value of the chain ID. By X I mean this X basically. So we're getting the HEX value, the X value of the chain ID, and that's what we're sending to the RPC. And once we do that, it's going to trigger your wallet. And if you already have that network on your wallet is going to ask you to confirm that you indeed want to switch. Actually, because you cannot see my MetaMask pop up, I hope you are able to like understand this. But basically, once you click on confirm that you want to switch this network. So for example, I'm on Celo right now. And if I click to switch to Aurora, my MetaMask pops up and asks me that this switch will switch in a selected network within MetaMask to a previously added network. So I'm going to click on switch network, and then as you can see, it switches to Aurora. So that's basically how it's done. And so once we switch to Aurora, we then update our state. So basically now we know that you've selected Aurora as the chain you want to mint to. And so what we do is we update the state to say that the selected chain is now this chain ID, so that when we want to mint, we take note of which network to actually send our minting request to. We're going to be getting to the minting request part in a bit. But yeah, so we just do that. And if you're curious about this, so because the anything that has to do with your wallet change, basically like it basically reloads the whole screen. So if it reloads the whole screen, then it means that the image that we uploaded, the CID is going to be lost. So because of that, we are setting it in storage. So the VM provides this API called storage.set. So this allows you to be able to actually make use of your local storage. Actually, the index DB is what BOS uses. So we actually just save the already uploaded image, we save it to storage so that we do not lose it, and then you don't have to like start all over again. So that's what this particular line of code does basically. And then obviously there is the on-chain description, which is used when you when you input anything in your description. So basically, this updates our description on the state to always point it to the latest description that you have for your NFT. And this undo toggle, as you can see, basically most of these changes has to do with the state. So what we're doing is just we're making sure that on every action that the user performs, we are updating the state appropriately. For example, this show band, as you can see, it is disabled, but then we click on enable, we can see that it is now enabled. So this is the function that was responsible for that. The undo toggle, it basically just updates the show band and it negates the current show band function. So as you can see now, it is disabled, but then if we click on disable, you can see that the show band is now disabled, and then you can now click on enable to enable again. So that's basically that. And then we could then go to the mint function and see how exactly that works. So the mint function is somewhere up here. Yeah, undo mint. So we can see where it is called, where it is being called here. Mint to Aurora. So basically, it's going to be mint.
This is the same mint function for no matter what chain, even near. Like you put all the logic in it.
Yeah. So we're going to be like dissecting that function to see how that actually works. But we use one mint function for all the chains. So as you can see here, it says that mint to Aurora. So if you change to any chain that you change to, it's going to basically tell you, do you want to mint? So it basically makes you aware that you are on a different chain. So you can see it's telling you mint to Avalanche. So at this point, you know that you're trying to mint to Avalanche. And if you change to near, it's going to tell you mint to near. And then, like I said, for this mint to, the default address that you mint to is your address, which is the address that you use to connect to the component. But then you can always input a different address and say, no, I want to mint to this address. And that will basically allow you to mint to that address. But yeah, if we then go to this function and see how it works, so we can see, ignore the console logs, please. So we can basically see that this function is first checking to see that we have a state.image.cid. So what this is checking for is to actually make sure that we have uploaded an image and that the image has been uploaded successfully to IPFS, and that IPFS actually returned an hash for us, because the hash is what we're going to be using in minting this NFT. So once we confirm that that is done, we also confirm that that your NFT has a title, that you have entered the title for your IPFS for your NFT, and if you have not, we toggle the alert to come up, and that is why if you click on mint, you can see it says here that please enter a title for your NFT, and then we also we set the timeout, and that's why you see that after about 3 seconds the alert button goes off, and we also check the same thing for the description. And so that would mean that even if you entered the title but no description, it's still going to tell you the same thing for a description. So you need a title and a description to actually mint the NFT, and that. So now this is where the upload function now starts. The minting function now starts. We first check this. So because like I said that even though we support about 5-6 different chains, these chains can actually be grouped into 2 networks. There's the one on the near blockchain, and then on the near network, and then there's the one on the Ethereum compatible networks. So so that means that we have to do 2 different checks. First, we want to check if if you are trying to mint to near. So obviously, like I said earlier, once you switch chain here, we update the state variable to make sure that we keep track of the chain ID that you want to mint to. And as you can see here, we are doing a if statement to check the state of selected chain. So we're checking the current selected chain. If it is 0, that means it is near. Now, if it's not 0, then that means you're trying to mint to Ethereum. So let's say you're trying to mint to Polygon, for example. If we check so I want us to first look at the Ethereum code before we then check the near one. So first we get the network ID, and then we check if we're trying to mint if we're trying to mint a soul-bound NFT token or just a normal NFT token. So basically, this contact address is going to be containing the contact address that you want to interact with, and that is why we are doing a one-line if check to say, okay, if state dot is soul-bound, which means that if soul-bound is enabled, then that means you actually want to mint to the soul-bound NFT address. If not, then we're selecting the normal NFT address, and then we are building this contract. So this is how you build contract with Ethers in Ethereum. Basically, there's an Ethers function called Ethers.contract, and then what you pass in to this contract function is the contract address, which is the CA that we stored in this variable. And then if you do not forget, this mint single is actually the API for interacting with this contract. So like I said, all contracts follow an NFT standard. So that is why we can use one API for every contract interaction when it comes to NFTs, because we can rest assured that every of these contracts follow this NFT contract standard that was stipulated on the Ethereum chain. And then we pass what we call a signer. So this signer is basically the address that was connected, and this allows you to be able to actually call the blockchain. So once we have built this contract, once we've instilled this contract, we then build the metadata. So there's something called metadata for NFTs, which is basically metadata is basically just information about the NFT. And as you can see here, it contains the name, the description, the properties, and then the image. Now you can see that the name we did state the title. So the title is basically the name of the metadata, the description, and then properties. So properties contain something like the properties of your NFT. For example, was it hand-drawn art? Was it an AI generated art? Was it street photography, or whatever property you could actually? So basically, just characteristics of your NFT that you'd like to put there on chain. But for now, we're leaving as an empty array because we're not providing. We didn't provide an input box for that yet. And then there's the image variable. There's the image field, which basically contains the IPFS hash of the image. So basically, you can see that we concatenate the IPFS URL with the hash that we got from IPFS. So this is basically a public gateway to be able to like view the NFT that you uploaded to IPFS. And then so basically this might be a bit slower, but we have your own gateway on IPFS. IPFS offers private gateways. It allows you to load your images faster, but that's by the way. So we built this image URL so that other services can be able to like display our NFT. So for example, if you go to like something like OpenSea, this is the field that OpenSea uses to display your NFT. They basically just load this URL and then you're able to like see the image of your NFT. So so what we want to do now is that we want to upload this metadata to IPFS. So now that means we are doing two uploads to IPFS. First, we are uploading the image itself to get an hash, and secondly, we are uploading the NFT metadata to IPFS. So the NFT metadata, like we see here, is going to contain the name, description, properties, and then the image URL. So we make an async fetch, we make a fetch request basically to this URL. So this is actually a near social backend that helps us to upload files to JSON files in this case to IPFS. So we do a post request, and then the body is the metadata that we're trying to pin to IPFS. And then once we do this request, we are expecting a response from this URL, which from this fetch call, which is basically going to contain the hash again. So for every upload that you do to IPFS, you always expect to get an hash back. So this hash is the unique identifier to whatever object you uploaded to IPFS. So you can be able to access this file or this object anywhere basically. So we wait for the NFT. We wait for the response. We get the hash, which is also called the CID. We then compose an ID for this NFT we're trying to mint. Now, how do we compose this math? So you can see we are doing just random. We're getting a random number to generate an ID for this NFT that we're about to mint, and then we are doing. Oh, sorry. So that was the near code, and I said I wanted us to look at the Ethereum code first. So once we pin the metadata to IPFS, we generate an ID. We already have the hash of the metadata. We are then going to do an ethers dot. So then we want to get the recipient. Now the recipient is basically who is trying to send this request. So ethers.send this RPC request gets the account that is connected to this component. So if we connected with this account OXE42C, that's what we're going to be getting here. But then that is if we are not that's if we've not entered a recipient here. Like I said here, that we could actually decide to mint to a different address. So we could copy an address from Polygon Scan and then paste it here. So if our component does not find any address here, then it means that it's going to mint to our own address. So as you can see here, we are doing contract.safe. We are doing contract.safe means state the recipient or the recipient. Now, this safe means is we can see it. You can see it up here that it takes two function method. It takes two parameters basically. It takes the address that we want to mint to, and it takes a URI. So if we so we are basically passing the address I want to mint to, which is the recipient that we pasted here, or our own address that we used to connect to the component, or the IPFS hash, and the IPFS hash. So those are the two parameters that it takes. And then so And if we take note here, we are doing a one-line ternary check, and we are using a ternary operation to actually do this main thing. So we're saying that if state dot is so bound, so we're saying that if we enable so bound here, so if so bound is enabled, then we're going to be calling this part of the code. But if so bound is disabled, then we are going to be calling this part of the code, which is just the main function. So for so bound, we're using safe mint. For normal contract, we're using the main function, but it takes the same number of parameters, which is the address that you want to mint to. Sorry, no, it does not take the same number of parameters. If we actually check up here, we can see that this mint function takes the address you want to mint to, the ID, the amount you want to mint, because this is an ERC 1155 contract. So it takes the amount you want to mint, it takes a URI, and it takes an arbitrary data. So that's basically it. And as if you check here, we are passing in the address you want to mint to, which is the state recipient or our address. We're passing in an ID, which is the ID that we generated, the random ID that we generated, and then we are passing the amount as 1, and then we are passing the URI, which is the hash that we got back when we print this metadata to IPFS, and then we are passing an empty data. So this works means we are passing an empty data. There's no data to pass in at this point. And then, so this is every contract interaction is always returns a promise. So every blockchain call is a promise call, and then we have to like await the response of that promise call, and then we do that by saying that we are doing a .10, and then we await the transaction hash, and once we wait for this transaction hash, we are going to get the receipt of this particular transaction. So the receipt is what we used to it was what we used to compose the transaction link that we saw here earlier after we had minted our NFT. So once you mint your NFT, after minting your NFT, we wait for the transaction to be mined, sorry. And once the transaction is mined, we get the transaction receipt, and then we use that to build a URL where you can actually be able to view your transaction on the Explorer. So as you can see here, contract addresses, state.selected change. So if we check this, we basically check this, we would see that it was an array that contained let's just check it here. It was an array that contained so this is it. We can see that this is the host. This is the host name for the explorers. So this is the host name for the explorers basically, and then we add the receipt to the end in that code. So basically we concatenate this starting host name with the receipt hash that we got back from the transaction call process, and then the user can click on that link, which then takes them to the blockchain as it happened, which then takes them to the Explorer link and shows them the details of the transaction as it happened on the blockchain basically. So this is basically everything that has to do with the Ethereum minting process. And then if we check the near minting one too, so basically we're saying that if the state selected is 0, then because we already in our component we gave near the chain ID of 0, then we're sure that all right, this person is trying to mint to the near protocol. And what that will then do now is that it will mostly follow the same process like Ethereum. For example, we're still going to be pinning this metadata. We're still going to be generating metadata for our NFT, and then we're still going to be pinning it to IPFS through this URL. And once we do that, we make a post request, and then the body is the metadata that we're trying to pin to IPFS. Once we do that, we get a response back from IPFS. We take the CID of the response, we generate an ID, and then we do a near call. So there's two types of calls to near. Basically, there's the near view and the near call. So the near view is basically you trying to like view the data that is already being stored on the blockchain, while a near call is you trying to like post the data to the blockchain. So it means like you're trying to alter the state of the blockchain. You're trying to like add something to the blockchain. That's why you have to do near call. But in cases where you are just trying to view data that's already been stored on the blockchain on near, then you basically just have to do near.view and then pass in arguments if required. But near.call, it means that you're trying to alter the state of the blockchain. And the arguments that near.call takes, it takes the contract name, which is the contract you're trying to interact with, which was the contract that we saw the functions there. And then the method name, which is the method name that you're trying to call on that contract, and then the arguments. So basically, this argument takes a token ID, metadata, and then the receiver ID. So the token ID is basically the token that we want to use for the NFT, and then the metadata is something that is required by the NFT standards on here, and basically just the title, description, a media, and a reference. So the receiver ID is the person that is going to own the NFT, which could either be you, or if you were trying to mint it to someone else on behalf of someone else, then it's going to be that person, and that's why we are doing state the recipient, which is in the case where you pasted an address into this area, or account ID. And account ID is basically the ID that is connected, your near wallet. So so that's just the argument. And then for the near call, you pass in the gas and the deposit. You actually need a little bit of deposit. So the reason why you need deposit is because if you're trying to save data on the near blockchain, you have to pay for what we call storage. So you have to pay. I think as at now, the ratio is about 1 year for every 100 kilobytes that you are trying to store on the near blockchain. But this is basically some bytes at best. So it's going to be the amount you are going to need for minting is going to be just negligible basically. So, but you pass in some deposits, and then this near call is going to trigger a near call, literally. So what it's going to do is going to call the near blockchain and say that I want to store this particular information on the blockchain. And once that is done, you're going to get a link that's going to lead you to an explorer where you can see your transaction and see that it was that everything worked well. So I think we could just do a few more demos because I've only limited on Polygon, but I could try and mint on some other chains basically. So but after that, I think that'd be all. I think I hope that I've gone through the most intricate parts of the component, which is basically just how we handle state changes for network changing and also minting. I think these two are like the most important parts, how we handle network changes and how we handle minting, and basically also uploading to IPFS and stuff like that. So if there is any question, basically I'll be taking them now while I try to mint.
Yeah, I got a few questions. So like when you're doing this, you're doing straight to mainnet, or like what about, I mean, you can't really interact with a mainnet gateway on near testnet, but since you're able to switch networks, ooh, are you doing testnet development on Ethereum, or like what's kind of how would that look like?
Yeah, so for this component, basically there's no mainnet, there's no testnet version. But in cases where we would want a testnet version, then that would mean that we first of all have to change these contracts, because these contracts are mainnet contracts. And then the one important thing again would be the chain IDs. This is what will decide whether your minting request is going to be sent to the mainnet or the testnet. So if you want your request sent to the testnet, you have to change your chain ID. So in this case, Polygon, it would be Mumbai, and then Mumbai chain ID would be 8001, and this would make sure that when you want to do your NFT.mint, when you want to do your contract.mint, it's going to make sure that the contract, so it's going to make sure that first the contract that you're calling the testnet version of the contract address. So if you're trying to call a mainnet contract on testnet, then it's going to error out the transaction is going to actually throw an error. But like I said, the two things, if you want to like make a testnet version of this component, then the two things that you need to change are the contract addresses and the chain ID of the network. So once you change the contract addresses to the testnet version of the contract, and you change the chain ID to the mainnet chain, then you'd be able to like connect to mainnet to the mainnet network on your wallet, and you'd be able to like send the request to the testnet rather. Sorry, I think I messed it up there. So you'll be able to like connect to the testnet on your wallet, and then you'll be able to like send the request to that testnet address. So once you change that contract address to testnet, and you change the chain ID, you'd be able to do that. I don't know if that answers your question.
Yeah, I mean, and there's something kind of important to note there. So because you're, like, you can add, so these components are published on your mainnet, and this gateway is connected to near mainnet. But like the whole Web3 Connect is built within the VM. All of the like Ethers.js is built within the VM, so you can easily switch between testnet networks on a mainnet near component, where for near testnet it's not so straightforward. People traditionally deploy it on testnet on like test .near.social, where that part of switching it may not be as straightforward. But that's something I think is really cool, that you can have mainnet components that interact with testnet, or even toggle to mainnet for EVM blockchains. What was like building this all out? I mean, originally it started as just near, and then you added chains. Like, what was kind of the biggest lessons from like doing this exercise, especially early on when BOS was starting?
Yeah, so I think again the biggest thing that I have to take notes, I think it's something it's something that I've stressed on this whole session, is the state management, and basically make sure that whatever action you're taking, you're like appropriately recording it in your state, so that you don't actually lose where you are. For example, if you're trying to change state, there was a time without so if I try to, let me just try and do this. If I try and remove, I talked about this word, this particular stuff, but now it's set in my storage, so it might not actually work. If I remove this particular line of code, anytime I try to change my anytime I try to change my my chain, if I try to change a selected chain, it was always going to reload the whole thing. So basically, it was going to reload my whole state, and then I would find out that the image that I already uploaded to IPFS was gone. So I have to like take care of that to make sure that on Ethereum requests, my whole state does not reload, and even if it does, I do not lose I do not lose possession of my CI of the hash of this image that I already uploaded, because that will mean that I have to start again. I'd really like to demo that, like to show that, but I'll have to clear my my index DB so that I could just show us that. But again, what I was trying to get to is the fact that state management was actually my biggest headache. I had to like make sure that I was managing my state pretty much very well. And then also interacting with Ethereum was, I mean, it was been a while I built this. Interacting with Ethereum wasn't really straightforward. As you can see, I had to like I had to like check the I think I have to check MetaMask RPC website to actually get this method name, so that I would be able to like switch addresses and all. So I had to like do a bit of research on that to be able to switch network, but that worked out fine. So those two basically interacting with Ethereum wallets and also state management was like, yeah, they were like the two big stuff that I had to
And then what about like
deal with.
estimating gas for like near mints and all that? Like what is what's that like? Like how are you generally doing that?
How am I doing what?
Estimating the gas that you need for the mint.
Yeah, so for I think this question was for near, right? This question is more for near, right?
Yeah.
So yeah, I mean, so for near, basically what I had to do when I first started was more of trial and error for me because at first I think I added. I mean, you can never add too much gas. Is the case with near because you are always refunded. So even if you, I mean, so you could when you are in doubt, you could basically just add a lot of gas, and you could know that you're never going to lose because at the end of the day, whatever gas was used is deducted, and whatever remains is actually given back to you in the case of near. So you always know that there is no adding too much gas. But then to find out how much gas I actually needed, what I did was I looked at the transaction and I checked how much data I'm actually going to be storing. So for the NFT mint, for example, I was storing about because I mean, and this was easy for me because I actually wrote the contract, so I knew how much data I was storing for this particular function. So I could be able to tell how much kilobytes I was using for this transaction call. And then, like I said, on the near docs, they actually tell us how much how much near you pay for kilobytes of data that you're storing. So basically, like I said, I think for 100 kilobytes, it's 1 year. So if you just slash two, I think for this NFT function, I can't remember. I think I was storing about some. It wasn't even up to kilobytes really. Yeah. So I was able to like deduct close to how much I would be needing for gas and as you can see, that was why I was able to like output them I'm basically coding them here because I was sure that I would not be using more than this amount of gas basically.
Okay, awesome. We're pretty over time, but thanks for going in depth and on this. Is there any kind of last words or maybe kind of feedback on developing on BOS or like what you would like to see maybe in the upcoming quarters in terms of like dev tooling or things to kind of make you build faster?
Yeah, yes. So I think one of the things there was another component that I built, which was mainly Ethereum, and one of the things I would have loved to have on BOS was so that you'd be able to like use external providers. So for now, BOS mainly relies on your wallet provider, and in this case, only MetaMask. So basically, if you're not connected to MetaMask, you cannot do anything on BOS. So whereas if you're able to like use an external provider, you'd be able to at least read from the blockchain. So I mean, there was this component that I built. Maybe I'll be demoing that in some other sessions, which was for a competition and against staking. So it was basically you could stake some gains token and it was basically about the gains network. And sometimes I would, without user connecting, I would want to show user data from the blockchain, like how much gains was being staked and how much the current staking pool and stuff like that. But you cannot do that if the user does not connect their MetaMask wallet. Whereas if the VM add a way for you to use an external provider, say something like an Alchemy RPC or a general RPC, you would be able to do that. So I think that would be nice. Basically, just allowing us to like connect to an external RPC on in our code, so that we could pull data from the blockchain without having the user actually connect to their wallet. I don't know if you feel what I'm saying, but I think that would be really really nice.
Oh, awesome. Yeah, that makes sense why a lot of the DeFi applications that are being built right now, they require you to connect to actually anything. So but yeah, um thank you so much for coming on and yeah, till next time. See you next week, everybody.